Your quizzes are graded. They're in the grade book. For the most part, you did pretty well on them. I will hand them back tomorrow for you to keep forever and ever. We'll go over them as well. Just need to have a couple people make them up, so hopefully they'll get them made up. So remember, we are hoping you guys get those graphing calculators because we're going to be teaching you how to use graphic calculator as a tool. It's a pretty darn good tool. I recommend you purchasing it if you plan on going to college. It will help you through multiple classes in college, including chemistry, statistics, and math, and all sorts, okay? So, but we're going to start talking about scatter plots and lines of regression. Okay, you've already done this in science. You've already created lines of best fit. Okay, so problem A shows the time of days of winter after December 1st, 2009, and the snowpack at the tree line of Wyoming Peak. Okay, so we have a certain date starting, looks like December 21st, so time in days. If December 21st is our is the day that we're starting, day 0 would be December 21st. Day 10 would be December 31st. Day 20 would be in January. Day 30 would be in January. Day 40 would be in January. And day 50 would be in February. Okay, and you're talking about the amount of snow pack in inches. What is the independent variable, x, and what is the dependent variable, y? What do you think? What would our x value be? Time. What would our y value, our dependent, be? Snow. Okay, and it happens to be in inches. Time and days, so you could list that, hey, this is time and days. Snowpack in inches, the double tick mark could mean inches. Okay? So, is this time and days starting at the beginning of the time when the Earth just happened? No. December 21st, 2009. Okay? So this means something here. Okay? So let's move forward and see if we can investigate how this might go a little bit. All right, so our independent is our x value we said was time. Okay? So we said this is time down here. And this was in days. Okay? And then snowpack in inches. This. Okay? So this is our y component, this is our x component. Agree? So the graph, the grid, we're just using, this is actually called quadrant 1. Quadrant 1 deals with when you're talking about just positive values. Okay, your x and your y component are both positive. You don't have a negative x, you don't have a negative y in this case, but we'll talk about what that might mean a little bit. So time in days looks like 0, 10, 20, 30, 40, 50. So let's think about this. If I start at, bless you, if I start at 0 here, I could, should I go 10, 20, 30, 40, 50 and have my graph end here? Should I go every other? So 10, 20, 30, 40, 50. Should I go every 3 where I go 10, 20, 30, 40, 50? Okay, there's different ways to do it. So you're going out 50 days. Agreed? So let's maybe do this. Take that out to 10. Take that out to 20, 30, 40, 50. Of course, this could continue. This would be 60 then. 70, 80, 90, all the way out to 100 days. Okay, 100 days after December 9th. It's over 3 months. So we're into February, into March. Okay? Is there snowfall sometimes in March? Sure. On this particular mountain, there might be. All right, and then we're talking about the snow in inches. Okay, so it's snow in inches. So we have 35, 52, whoops. 35, 52, 78, 92, 112, and 130. So probably start from 0. Count by 15s? That might be a good idea. 15, 30, 45, 60. That's hard. Oh. Count by 10s? I don't know.
10s are easier.
10s are easier? I don't know. I think both might be good. All right, so.
I vote 10.
All right, so.
How about 7s?
Sevens. Let's go by 3.627.
That's so hard. Are you trying to make
All right.
my life hard?
All right,
I'm just in math.
so should we count at every line?
Yes.
So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 10, 20, I don't even know where we're going up to. What's my highest number? 130? So we need 13 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Would this be okay where our graph could end right there?
Yeah.
We should skip lines.
We could skip lines, but I bet you we'd go too much. But if we went by a different value, if we went by 15s, we might be able to.
Oh my goodness.
But let's just take it to 10. So we'll make each one of these marks 10. So notice, in the y direction, are we counting at a different rate? Yeah. 50, 60, 70, 80, 80, 90, 100. That's right. 60, 70, 80, 90, 100. 130, 150. Okay, I guess we could label them all if we wanted to, but if we didn't, we could easily say, well, that's 60, that's 70, that's 80, that's 90, 100, 10, 20, 130, 140, 150, 160, 170, 180. Maybe? I don't know. This very top line could be 180. Do you get the gist of the counting?
Yeah.
Okay. All right. So let's see. So 0 days. What did 0 days represent? What date? December 21st, 2009. Okay? All right, so 0, 35. So 0, 35, that's about right here. Agree? Okay. 10, 52. 2078. So 60, 78. 30 and 92. 40 and 112. And 50 and 130. So looking at our points that we had drawn, does everyone feel comfortable with how we plotted those points?
Yep.
Does it look like it could form into a line?
Yep.
Now let me ask you this. If I continue to go this way on our x-axis, if I continue to keep going, is it going to get to a point where the snow is going to melt? It's not here. Or will this snowpack continue well into the summer? No. So there's a certain window that we have to look at. Okay, at 200 days, way over here, would we still continue this growth? That's a lot of snow and a lot of days of snow. I guess theoretically it could. I don't know. All right, so then draw a line of best fit. How do we draw a line of best fit? What's the method to this madness? Any ideas? Yeah. Well, you try to. So I'm going to use my straight tool, and I'm going to keep it going. But that worked out nicely. That line of best fit looks like it's pretty good. Agree? Well, you could if you'd like, if you have one. Or a straight edge of some sort. Okay? Now let me ask you this. Is there sometimes strange anomalies that take place that might mean we get a little bit more snowpack on a particular time or less at a particular time? Sure. They're kind of outliers. They do happen. So it could be possible where we had some weird day that was up here, but our line of best fit, we're trying to incorporate as many possible points as we can, or in between as many points as possible. And when we start getting to our graphing calculators, the graphing calculator has a function that allows you to find two different values. One's an R value and one's an R squared value. R is just a distance. Okay, R squared is a two-dimensional square. Okay, and it's called a, it'll tell you what percent chance this line that we put here fits. And the closer your R value is to 1, the better your line of best fit. The further away, so if it's a R value of positive 1, it means you have a positive slope. If it's an R value of negative 1, you have a negative slope. If it's an R squared value, R squared is always positive because if you square a negative number, you get a positive number. Okay, and it has to do with the average distance away from each point. Okay, but we'll get more into that come Friday when we start talking about it. All right, let's see. So plot all the points on the graph below. Choose the appropriate scale to label the axes. I believe we did. Then draw the line of best fit. Does everyone feel comfortable so far? Anyone stuck on where we're at? All right, write an equation of the line of best fit. What are 2 points you would want to use? Okay. So our next slide, I'm not there yet, but I have this up still. What 2 points appear to be pretty good points? Do you think I should pick 2 points right next to each other, further apart, somewhere average in the middle?
Someone that goes to the line.
So goes through the line. So all of these kind of work out pretty nicely, how our data worked. So we chose pretty nicely. But a good rule of thumb is to try to find 2 points that are relatively far away from each other that the line happens to go through. Okay? And sometimes it's just eyeballing it. Okay? Depending upon what 2 points you pick, if you chose 2 points and your neighbor chose 2 separate points, you might get a slope close and you might get a linear equation close. So let me ask you this. If I had a slope of, say, 4/5, and your friend got a slope of 4/6, are those kind of close in slopes? Up 4, right 5, or up 4, right 6, are they kind of close? I mean, yeah, you're just using your critical thinking. So let's pick 2 points that we feel might be good. So I think this would be a good point, and I think this would be a good point. Why did I choose those 2? They're not really my end points, but they are 2 points that are definitely far enough apart that I think we could start doing some interpretation. So I'm choosing our second point and our 5th point. So our second point, if I just wanted to write this in, I'm going to make that as 10, 52. Agreed? And how did I get that? How did I get these points?
By looking at the graph.
Yeah, looking at the graph, and I made my graph by the table of values. So 10, 52, and 40, 112 are the 2 points that might work for us. Now, if you chose to do, say, 30, 92, you're going to have a pretty close answer to ours. Okay? So a lot of times, this type of math is good for doing predictions. But do you think, say, Dave Aguilera, who's the weatherman on CBS, do you think he uses only 2 plots of data to make a decision? No. Would you like to have a job that you can be wrong so often? Dave's my neighbor, and I always give him a hard time. But I also, I do. Well, because he's always wrong.
He's on TV.
No. Think about it. How often is the weather guy off?
Does he actually do the stuff?
Yeah, he's the meteorologist that looks at the models of data and makes the prediction of what might happen. No, he does the actual work to it as well. But all weather guys are.
Then why does it come on there?
Because people like to feel good about themselves going, oh, it might be sunshine today. Can you imagine having that job? I always give him a hard time. But, of course, I always have the dumbest conversation with him. I actually saw him last night. He was out with his kids trick-or-treating. He just came by. And you know, what did I say to him? Hey, it's a nice night. I'm like thinking, duh, he knows this is a nice night. What did he say? Could he have said to me, hey, it looks like your numbers look good on your house. You're a math teacher. You must know numbers. I don't know. I always say dumb things to him. Like, hey, it's a great day out. He knows that. He's the weather guy.
Mister, but they said it was the snow. Like, they don't know.
Yep, see?
Not today.
Wouldn't that be a cool job?
No, the other day.
I think it'd be a pretty cool job if you were able to be incorrect quite often. All right, but let's get back to our scenario. So what are 2 points we'll use? What 2 points did I pick? 10, 52
And 40, 112.
and 40, 112. So what kind of rhyme or reason went into us picking these 2 points? We looked at our data. We said these are kind of far apart, and they happen to fall onto our line of best fit. That was really what it went. It wasn't this magical scenario that we came up with going, oh, yeah, well, you always want to see if it's a factor of 10 and divided by 4 to get your y component. No. Okay? So use those 2 points to write an equation of the line. So how would we write an equation of the line? What would be the very first step of writing an equation of a line? We just quizzed on this.
Slope.
Find the slope. Yeah, baby. So I got y2 minus y1 over x2 minus x1. And so, let's see, I'm going to go 112 minus 52 over 40 minus 10. So 112 minus 52, help me out.
Is it 60?
Is it?
It is 60. It is 60.
Yeah, okay. So I get 60 on top, and on bottom, 10, 40 minus 30. 2 over 1. So I have a slope
2.
of just 2. Or 2 over 1, right? And remember, 2 over 1. In the y direction, it goes up to right 1. If it goes up 2, what's our y component mean? What does our y component on our grid mean? Snow in inches, right? So for every 2 inches of snow, what's our x component? N over 1. So for every 2 inches of snow we get, 1 day has taken place.
Hey.
Make sense?
That's sad.
Yeah.
I was really waiting for like a delay of school or like.
Oh yeah, it'll happen. I know he is mean. He's actually an awesome person. I really appreciate him. All right. So, you know what's nice about Dr. Bull? He gives a lot more snow days than the former superintendent. Our superintendent, Dr. Bull, that's our superintendent. He lives way down by southeast of Ponderosa High School, way down in Douglas County. They get pounded with snow down there. So he has called snow days based on his prediction at his home, where it's like this outside here. I see.
Why is he the superintendent for Douglas County? Why is he all the? Why is he?
Because his wife works here. He worked here. He worked his way up the ranks. And you don't want to be the superintendent of Douglas County.
I thought that at a certain point, like you can't, if you have a certain amount of, or just have off days like that, like after school, you have to push another day.
Yeah, supposedly. I've never been like that. All right, so hush. All right, so we need to figure out what points to use. So I think this might be an okay value to plug in here and here. What do you think?
Yeah.
So I have y minus y1, which is y minus 52, equals 2. That's our slope. X minus 10. No, it'd be the same exact equation. Okay? Use those 2 points to write an equation of the line. Show your work. Okay? That right there is our equation of the line. That's our equation of the line. Okay? So I would say if it just says, hey, we want to find the equation, give us this. If they wanted us to take it a little further, we certainly can distribute that 2 over. And this is how the graphing calculators will accept the problem. So let's bring this up here so we get a line of best fit of y equals 2x plus 32. So minus 20 plus 52. I added 52 plus 52.
Yeah.
So negative 20 plus 52. So y equals 2x plus 32. All right. So this is all information that we have done. Could we have stopped right here and said this is our equation? Absolutely. If we're going to start using the graphing calculator, this might be the one we use. Okay? So our next stuff says, does your scatter plot have a positive or a negative correlation? Does your scatter plot have a positive or a negative correlation? So this is when you look at your slope. Is your slope positive or is it negative? What was our slope in that equation?
Positive.
It was positive 2. So do you think it's positive or negative correlation? It's positive. It is a positive correlation. Our slope is positive. Therefore, it's positive correlation. What is the slope? What did we find it to be? 2. Explain what the slope of this line tells us in this situation. Be specific. Use complete sentences. So we know it's 2 over 1. So this is 2 inches. 1 day. Inch over day. So for every 2 inches of snow, 1 day takes place. For every 2 inches of snow, 1 day takes place. That's what our slope means in the context of this problem. What do you think? Is that verbiage we might be able to understand? Hey, mister, I'm not good at writing sentences. Nor am I. I'm just looking at you have to write something. Some of the answers on some of the questions. You know, hey, are these lines parallel or perpendicular? Or are these 2 lines parallel? Yes. Explain. Just crickets. There was nothing. It was like, ah. So that was only some people, not all. Some of you wrote very well and did very well on this. What are the coordinates of the y-intercept? Ooh, what was the equation? What was the equation we wrote? Y equals 2x plus 32. So what is the y-intercept?
32 days.
Careful.
32.
It's y-intercept. What's the y-intercept always? What's the y-intercept always? Huh? A point. So, what does the y-intercept tell us in the context of this problem? What was 0? What did 0 mean?
At 0 time. 0 days.
0 days. What day did we start on?
Since 0.
No.
December 21st.
How much? Cool.
Oh.
So, being December 21st, was it?
Yeah.
Equals day 0. Okay? Explain what the y-intercept means in the context of this problem. What does the 32 mean? That's a y component. What do we label the y component? Number of inches of snow. So, on December 21st, was it 2009?
Yep.
Yeah.
2009, there was 32 inches of snow on the ground. No. But it has to start someplace, right? And what's significant about December 21st? Does anybody know?
Isn't that actually a date?
What?
Not like
It's a what? The solstice. So what does the solstice mean? It's the first day of
Winter.
Okay? So the first day of winter. Sweet, look at this. We tie into other classes. That's awesome. So on December 21st, 2009, there was 32 inches of snow on the ground. Does that mean between December 20th and December 21st, 32 inches of snow fell? It could mean that, but it could mean that it had been snowing already, and by the time we got to the winter solstice, we had already 32 inches of snow that had accumulated on the ground. Now we want to go further to see what this will do. Let's see. How are we doing? We all right? Use your equation to find the snowpack on Wyoming Peak 25 days into winter. Okay, what was my equation again? Y equals what? 2x plus 32. So we want to know 25 days into winter. So if I plug 0 in here, that means, hey, that's our y-intercept. So at December 9th, we have 32 inches. If I plug 1 in here, that's December 10th. If I plugged 2 in here, that would be December 11th, so on and so forth. But we want to do 25 days into, okay, so December 9th. So let's think about this. December 9th, if I add 25 to that, I'm going to get to 34. Is there a December 34th?
No.
No, what day is this?
January 3rd.
Yeah! Awesome! So this is 34 days in, so this is actually going to be January 3rd. Very good. It's no longer going to be 2009, it'll be 2010, right? Because New Year's. Okay, so let's figure out, where should I plug this 25 in? Should it go in for the x or the y component? The x, because we know the x represents what? The days. Good. The time and days. So I'm going to take this 25, I'm going to plug it in right here. So y equals 2 times 25 plus 32. So y equals 50 plus 32. So y is equal to 82 inches of snow. So 25 days after winter has taken place, after winter solstice, we now have 82 inches of snow. That's deep. That's a lot of snow. That's good skiing weather right there. Woo! Yeah, but you can ski down it really well. Woo-hoo!
If it was that, it probably wouldn't.
82-inch base. How many feet is that? Anyone know? Oh.
I know. It's like
12 goes in 82. Why am I using 12?
Inches.
Inches. So
It's 8 feet.
7 feet. 8 feet?
No.
8 times, that's 16.
Well,
Nope.
actually,
Nope.
it's
7.
7.
Maybe 14. Nope. 6.
It's
6. That's 2. Hey, 6. And that's 12. That's a. You got a remainder. So it's over 6 feet of snow. 6 feet of snow. You know I'm like a real tall dude, but I'm not even 6 foot tall, so that snow's deeper
You're
than me.
6 foot.
No, I'm SMall.
I'm not even saying.
I'm like 6'4".
Me?
that's
No,
what
I'm SMall.
Like 6'6".
No, I'm SMall.
You're a what?
I'm SMall. Small.
Small. I get it.
All right. So we just use this as in the context of the problem. It's not a difficult thing. How many days into winter will the snowpack on Wyoming Peak be 100 inches? Okay, what was my equation again? Y equals what?
2x plus 32. The 100 goes in the y.
Yeah, the 100 is our y component. So we're going to put that there. Is that okay?
Yep.
Hey, how do I solve for x now? Help me out. Yeah. Subtract 32. So if I subtract 32 from both sides, what's 100 minus 32? How much? Huh?
78.
78? Let's see, is that 8,
No.
9, 68?
No.
Right?
Close.
Divide each side by 2. So we get x is equal to 12. 34. So 34 days after December what?
9.
21st? 34 days after that? we're gonna have 100 inches of snow up there if this model continues. That's a lot of snow.
That's 11.
Huh. All right. That, I believe, is the whole problem. What do you think?
Oh, can you go back?
Yeah, sure. That's the whole problem. Yeah.
This is kind of like an off-topic
Sure.
question, but like how many feet of snow do we have to get to have a snow day?
There's two factors that go in. One, are we adding to the accumulation on the ground, or is this fresh? Two, how cold is it? So there's kind of fun. Sometimes it's too cold. They can't start the buses because the diesel fuel gelled. And so that sometimes dictates. So we might not have a snow day, but it might be too darn cold for school day. So
Or it's too slippery.
yeah.
Wet ice.
What's kind of sad is I drive to school. I usually get to school before they call it the snow day. So I'm usually woohoo! I'm all over the place, man. I hope it's a snow day.
You get to school at like 4.
I got here this morning at 5:45.
Whoa, man.
I don't even get up at that
I
time.
wake up at
Oh, I'll call you. I'll wake you up tomorrow. Hey, what's up?
No.
Wake up, wake up,
My
wake
dad
up, wake up.
gets the call at like 4 in the morning.
Okay. All right. Here we go. Problem D. I don't know why this says problem B. I worked all summer to save money for my first semester of college. Oh, nice. Then I spent a little of it each week. These are the records I kept. So, time in weeks. So I went 2 weeks, I had $1,750 in my account. 4 weeks, I had $100 or $1,600. 6 weeks, $1,450. 8 weeks, $1,250. 10, $950. 12, $700. So I'm spending money a little bit. Yes. It's not a whole lot, but I'm spending a little. That's my walking around money. So what would my X variable be up here? Time and weeks.
Do we have to do this for homework?
Maybe. What is the dependent variable? Money. Money in my savings account. Right? Okay. So, can I move on?
Yep.
All right, so we have this information. So we said our X variable was what?
Time and weeks.
Time and weeks? Come on. Time and weeks. And then over here is money. All right. Taking a look at our data. We have 2, 4, 6, 8, 10, 12. So I'll call that 0. Should I go 2, 4, 6, 8, 10, 12?
We should go by 4s, but skip lines.
Oh. All right. So 0, 2, 4, 6, 8,
Last time we should go by 4s
10,
and just skip that line.
12,
Maybe before it goes
and then that's 14, and then 16, and 18, and then 20. You think that seems okay?
That's good.
Our data right now goes only up to about right here, right? And then what's the most money I have? $1,750? $1,750. All right, so let's call this 0. Maybe we'll call this 200. Let's do 200. 200, 400,
Let's go by 4.
600, 800, $1,000, 1,200, 1,400, 1,600, 1,800. Did I go high enough?
Yeah.
Yeah. Oh, good. Okay, good. All right, so at 2 weeks into our adventure of school, I had $1,750. 2 weeks in, I had about right here. Agree?
Yep.
And then at 4 weeks, I had 1,600. And then at 6 weeks, I had 1,450. And then at 8 weeks, I had 1,250. And then at 10 weeks, I had 950. And then at 12 weeks, I had 700 doll hairs. Okay, and then a line of best fit, we're going to try and draw our best line of best fit, right? I don't know. Is that all right? Seem okay? I don't know. It's not always an exact science. All right, so what can we do? I'm going to pick 2 points. This seems like a pretty good point, and this seems like a pretty good point. Agreed?
Yep.
Okay. All right. Where are we at? So what are the 2 points? I have the first and the 1, 2, 3, 4, 5th point. The first point is 2, 1750. And the 5th point is 10, 950. Okay, and again, those are the 2 lines that we chose. We're going to have to figure out the slope. So our slope equation, we have 950 minus 1750. 10 minus 2. What is 950 minus 1750?
950 minus 7. This is a negative.
It is negative. Good. Come on.
I'll look at
700. Where's 800?
Negative 800.
Negative 800 over 10 minus 2, which is 8. So I get negative 100. My slope with this linear equation is negative 100. So that's negative 100 over 1. So that means in the context of this problem, I spend $100 every week in the context of this problem. Is that a lot of money? No, not really. I mean, you're getting $100 right now to spend a week. You got some good walking around money. All right, so then I'm going to pick one of our things. So I'll pick this one. Okay, I just chose that. So I'm going to go y minus y1 equals m times x minus x1. So I get a y minus 950 equals negative 100 x minus 10. Maybe we should work this out. Okay, and then add 950. So there's my equation of my line. My y-intercept here is right here, 0, 1950. May I move on?
Wait.
I added 950 to both sides. I went plus 950 plus 950. Because when I distributed this over the parentheses, right? Okay. Does my scatter plot have positive or negative correlation? Why? What's going down?
The slope.
Slope. So this has negative because my slope happens to be a negative number. What is the slope? What did we find it to be just now?
Negative 100.
Negative 100. Explain what the slope tells us in this situation. I spend $100 each week in college. Okay? That's all it means. Spend $100 each week in college. We good? Still? All right. What are the coordinates of my y-intercept? What was my equation? Y equals what? Negative 100. X equals what? Plus what?
Plus 1.
Plus what? 1950?
Yeah.
What does the y-intercept? 0, 1950. But my data started at 2. Didn't it? At 2 weeks, I had 1750. 2 weeks into my semester, I had 1750. So what does 0, 1950 mean? Yeah, that's when I started. So, as I got to college, I had $1,950 for your spending money. Okay? Oh, we're good in there. We good? What was my equation? Y equals what? Negative 100x plus 1950? Use your equation to estimate how much money you will have after 14 weeks. So where does this 14 go in? X or Y? X, because this represents time. Okay, so 100 equals negative 100 times 14 plus 1950. That's negative 1400 plus 1950. So that means I am at $550. Time to go home and ask mom and dad for some more money. May I move to the last slide? The last slide says use your equation to estimate in how many weeks will it take for me to have less than $100. Uh-oh. That's danger. You're spending $100 a week. So y equals negative 100x plus 1950. Where does this 100 go? Into x or y? Y. Goes it for y. Subtract 1950 from both sides. Bless you. Bless you again. Ooh, cool. We'll get a positive answer, right? 18.5 weeks into college. I'm under $100. Oh boy, oh boy, oh boy. So, your homework, you have your book there? It is writing linear equations number 7. Number 7, let's see. 4.
It's 114.
114?
Yeah, like 114, 115.
Page 114, 115. Sweet! Finished at the bell. Have a great day, everybody. Take care of one another.